Hello, this is the experiment of measuring tension and normal forces. We're going to introduce two quantities, tension and normal forces. We're going to introduce two patterns at rest and accelerating. We're going to introduce two measurement equipments and how to use them to measure. That is the spring scale and the electric platform scale. And then we're going to introduce two experiments in the elevator. That's to measure the tension force and the spring force. Tension is the spring force and the normal force that we also call the pushing force in the elevator. Don't worry in case you don't have convenient access to an elevator. I'll explain what to do in case you do not have a convenient access to an elevator. Okay, first we introduce two quantities. The quantities are two forces. One is called tension. Tension is also called a pulling force. If we pull the end of the spring force and this spring scale tell us what the tension force is. If you look at this spring scale, it can measure up to 1 Newton. So that tension force is in the unit of newtons. All forces are in the unit of newtons. If you use a spring force, it lets you read the tension force. And this spring scale has a Newton scale. That's what we're going to read. So that's the first quantity. Second quantity, we're going to introduce what's called the normal force. So what's a normal force? Normal force means it's a pushing force. So this is a scale. You might think, hey, scale is for measuring weight. It is not for measuring weight. I want you to know that, okay? It's also not for measuring mass. In this case, weight and mass can be derived from the normal force we measure. So this lab will focus on measuring normal force. So if you put a piece of object on top of it, this object will push it down, and the reading is going to be the normal force. If it's in grams, it can be converted to newtons. If it's already in newtons, that's fine. If it's in ounces, it can also be converted to newtons. So this is a scale. So now we introduced two quantities. One is the pulling or tension force. The other is the pushing or normal force. If you put an object on the spring, you measure the tension force. You put it on the platform scale, you'll measure the pushing force. So that's the two quantities. Second, we're going to introduce two patterns. The first pattern is you make these measurements when both the spring scale and the electronic platform scale are at rest. So they're not moving. When it's not moving, we call it an equilibrium. As a matter of fact, when an object is moving at a constant velocity, we also call that equilibrium. So the first pattern we introduce is equilibrium. Okay, and that's how we're going to make these two measurements. And secondly, we're going to introduce a pattern that's called accelerating. So now let's talk about elevator. So elevator, we're going to run the elevator up and down 3 times, 3 rounds, not one single direction trips, 3 round trips. Okay, so when the elevator goes up and down 3 times, it must accelerate. So the second pattern is accelerating. Okay. And then you say, what if I don't have access to an elevator? Because we only need the elevator to create acceleration, you can simulate an elevator. Instead of going into an elevator, you can have somebody help you take the scale, either the spring or the electronic platform scale, and just move it up and down, up and down, up and down. When you move it up and down a few times, you have to be accelerating at some points. Okay, so that's the real or simulated elevator, and that's the second pattern. And here the measurements. So we're going to introduce some more details of these two measurement equipments. So here is the platform electric scale. This scale If you look at the on top, that's the printing on the outside of the container. It says the range is 100 grams. That means it can measure something as heavy as 100 grams. That's the most it can measure. If anything's more than 100 grams, you're not supposed to put it on it because that might cause damage. Okay. Once it's damaged, then it's very difficult to repair. We'll try to calibrate, but so just be gentle and be careful, no more than 100 grams. And then it says times 0.01 grams. That's 1/100th of a gram. That's the accuracy. So the range is 100 grams. The accuracy is 0.01 grams. So that means whenever you read, you can read up to 2 points after the decimal in grams. So this is an electronic scale. We are very lucky. This is a quite sensitive, quite accurate scale that we can use to make measurements. And that is why we can take it to the elevators and detect even small accelerations. Okay, so this is the electronic scale. I want you to remember it measures normal force. It does not always measure weight or mass. For example, when you take it to the elevator, it no longer measures the weight, no longer measure the mass, but it always measure normal force. And the next equipment we want to introduce is the spring scale. So this spring scale measures, if you look at the left side of the markings, measures up to 1.0 Newton. So that is the range. The range is 1.0 Newton. And the accuracy, if you look between 0 and 0.1 Newtons, there are 5 divisions. That means each division is 0.02 Newtons. So the accuracy of this spring scale is 0.02 Newtons. Okay, in summary, we introduced 2 quantities. We introduced the tension force, which is also a pulling force, but I expect you to use the professional physics word, tension. The next force we introduced is normal force, which is also a pushing force, but I expect you to use the physics word that's called a normal force. Normal means perpendicular in direction to the surface. So these 2 forces are both in newtons in the international standard units. In case you ever read grams or ounces, you can convert them to newtons. In case you're not sure how to convert them, you can simply Google it. Google does a very good job in converting these standard units. So that's the first thing. We introduce 2 quantities. And the next thing is we introduce 2 patterns. When you make these 2 measurements at rest, that means when they're not moving, that's also the pattern we call equilibrium. I want you to remember the word because when we are studying Newton's law in the next chapter, the first pattern we're going to use is equilibrium. And the second pattern we're going to use is accelerating. So when you put it in either a real or a simulated elevator, then the pattern of that motion is accelerating. Okay. And the third part is that we introduced 2 pieces of equipment. First is the spring scale with a range of 1.0 newtons and an accuracy of 0.02 newtons. And the next is a platform scale, which has a range of 100 grams and an accuracy of 0.01 grams. So that's the 2 forces we introduced here. And you upload your video or your images to discussion, and we're going to discuss how normal force and tension force may change in an elevator or at equilibrium. So that's for this experiment. We are now, and we're getting more familiar with the forces, the 2 patterns of motion and 2 pieces of equipment. This will help us greatly. You'll be a lot more prepared for the next chapter, which is also the most important chapter of the course, that we're going to introduce Newton's laws. You will be very prepared.